All right, here we are, take two. So I'm in the classroom for a video, first time in a while. Anyways, you guys just finished the quiz, nice job. I should have those graded for you tomorrow. Here is section 8.4. This is multiplying and dividing rational expressions. So an expression is not an equation, just an expression. And a rational expression is simplified when its numerator and denominator have no common factors. So here's again our rule. Basically, if you have a common factor c divided by c, you can cancel. This could be x divided by x. This could be the quantity x plus 2 over x plus 2. We are allowed to divide that out. So here's our first example. This is a rational expression, right? It looks like a quadratic divided by a quadratic. It looks like nothing cancels, and oh my goodness, by the way, if you are looking at x squared and saying cancel, we cannot do that. We cannot. It would be really nice if the book, and I would highly recommend it, that you put parentheses around this. This is one quantity, x squared plus 7x plus 10. We can't just come in and clean out the x squares. So if we had another x squared minus 4 up top, we could cancel. So it looks like nothing cancels. Well, the name of the game here is to factor. So we will factor the numerator, then factor the denominator, and then you see that these two factors cancel. And again, we don't cancel x and 2 and 2. We cancel the quantity x plus 2 with parentheses. And we're left with this simplified expression. So next step, multiplying. How do I multiply rational expressions? It's basically like multiplying fractions. We multiply the numerators and we multiply the denominator. So again, we multiply a times c and b times d. And that's how. And we definitely want to simplify. So here, example 2, you would hopefully you're recognizing these as two rational expressions, that you're multiplying them, right? You should, be kind of shaking in your boots. Do I really have to multiply this binomial with this trinomial? And no. So the first thing we actually want to do is see if we can't simplify. So here, and you should be screaming out, factor, factor. That's correct. So we factor this binomial into 2x times the quantity x plus 2. This quadratic gets factored this way, boom. And then we this line to me really just draws out. I'm allowed to cancel across. To see how there's a 2x here and a 2x here, those guys cancel. And this x minus 6 and this x minus 6, they cancel. And oh my, we're just having a field day here. X plus 2 cancels. And then try to keep track of what you haven't canceled. You should see that in the numerator we have an x minus 2. The book actually does this extra step. See how I just drew the line together? They just put it all together. But nobody wants to rewrite all these factors. So I think you're fine with doing what I did. And you're left with just x minus 3. So really fun, right? You can't see the way that was presented how much reduction can be done, but it happened. Why don't you go ahead and try these two? Hit pause. You definitely need to get into your factoring groove. So see what you can do. Hit play when you're ready. And there are the answers in red. I wrote in blue here the way I factored. Again, it's pretty unusual. I think in the homework there's maybe one problem that nothing cancels, right? So you should, if you factor and you don't see any canceling, I would check, and you really should always check your factoring, right? So hopefully you were able to get these two answers, and we'll practice this a lot in class. So here we go. I just had to come back and review section 4 from chapter 5, which is the sum of cubes and the difference of cubes. So kind of a pain, but we learned this semester 1. Hopefully you still remember it, right? So x squared plus 8 factors to x plus 2, and then x squared minus 2x plus 4, right? And this guy here would factor to the difference of cubes. So we'd square 2x and get 4x squared. Then we add the two pieces multiplied and get 2x, and then, sorry, I should have said subtract, and then get 1 squared, which is 1. So why do we need this? Well, this example. So notice here we have the x to the third plus 1. I always forget this when I look at this example. I'm like, oh my gosh, what do I do? But notice this guy here is kind of waiting for you. So again, high school math, something's going to cancel, and sure enough, when I factor the x to the third plus 1, this whole quadratic cancels. And when you use the sum of cubes or the difference of cubes, that quadratic never is factorable. Anyways, there's your final answer. And then dividing rational functions. Dividing is really the same as multiplying after you take the reciprocal of the second rational expression. Again, nice move here. You've got a over b divided by c over d, and it becomes a over b times d over c. So really, dividing is just multiplying. Just flip that second rational expression. So from here to here is just knowing that rule, and then you should be back in your comfort zone of multiplying. Before we multiply 3 and all this, let's factor. And when we factor, we can see that this cancels, 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 and just fun canceling, and you're left with this. So you've got 2 problems here. Definitely try 4. I would put a star next to. Something interesting is going to happen there, and then hopefully you can see this is the difference of cubes, and here's the second part of it. Anyway, see what you can do. Hit play when you're ready to see the answers. And there are the answers. So again, this is how that difference of cubes factors, and then these guys would cancel. I didn't rewrite it, but there it is, and you're left with this final answer. Here, when you divide by this rational expression, make sure you flip it, and then when you factor, the denominator goes up here and factor. But now watch what happens. So be real careful. You cancel. You cancel, 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 and all of a sudden, all you're left with is 9x. So it's very common for people to see that and just write the answer is 9x. But be careful, right? This belongs in the denominator, so you have to write it as 1 over 9x. And you can imagine the difference between 10 and 1/10, right? Just think of money. 10 and 1/10, very different. Hey, thanks for watching, and we will see you tomorrow in class.